So a pair of dice is rolled. What is the probability that the sum showing on a pair of dice will be greater than 6 given that the first die shows a 4? So we're going to use two approaches to solve this problem, and we should arrive at the same answer no matter which approach we use. So the first one, this is a conditional probability problem. So conditional probability. Because we are being asked to compute a probability given a condition, and that's given that the first die shows a 4. So if I know that the first die shows a 4, what I can do is then highlight that row. So the number on the first die is along the columns there. So that's this row here. Now, out of that row, those are all the ones where the first die shows a 4. What I want to do is figure out how many of those show a sum of greater than 6, so more than 6. So that would be a sum of 7, a sum of 8, a sum of 9, and a sum of 10. So the probability that our sum is greater than 6 given a 4 is rolled first is equal to, well, there are 6 options that we roll a 4 first, and then out of those there are 4 that the sum is greater than 6. So sum is greater than 6, there are 4 of those. Given that the 4 is rolled first, there are 6 of those. So we then simplify, put that in lowest terms, that's going to be 2/3. Okay. All right, so now let's look at it from a different perspective. Okay, so same problem, still conditional probability, but let's use the formula for conditional probability. Which says, if I want to calculate the probability of event A occurring given that event B has already occurred, this is the probability of A intersect B divided by the probability of B. All right. So first off, if A is our sum is greater than 6, and B is a 4 on the first die, then the probability of A intersect B. So the probability of A intersect B, so that's a sum is greater than 6 and a 4 on the first die. So 4 on the first die, so that's this row here, and a sum of greater than 6. So that's those. All right, so that's how many there are. But what's that probability? Well, that's 1, 2, 3, 4 out of 36. Right, so we're just considering that one event, that one outcome. That if you have a 4 on the first die, that the sum is greater than 6. So a sum is 7, 8, 9, 10, 11, or 12, right? That's the maximum sum you can get. That's 4 out of 36. All right. So now the probability of getting just B, so the probability of getting a 4 on the first die, well, that's that entire row. So that's, oops, didn't want to do that. Undo, I want a regular pen. So the probability of B is we've got 1, 2, 3, 4, 5, 6 possibilities out of 36. So then when we divide those, so 4 divided by 36 divided by 6 divided by 36, that result is 4 over 6, or simplified to 2/3. Okay. So we notice that this formula for conditional probability, right, again, the condition was B, that we roll a 4 on the first die. So it's set up that we have the intersection of the two events. So the sum is greater than 6, and we get a 4 on the first die. So that was our 4 entries in row 4. That was our 4 out of 36. And then the probability of getting B, those are the same, is just getting a 4 on the first die. So that's 6 of those. So again, that's the entire row 4. So we end up with the same answer. So I hope that clarifies things. Thanks.